So in this video, we're going to talk about the trigonometric functions, now dealing with some special triangles and not necessarily angles that fall on the coordinate axes on the unit circle. So the first one we're going to look at is the 45, 45, 90. So I'll go ahead and just draw a standard picture. We'll say that this is our 90-degree angle. 45 degrees is pi over 4, so I'll mark this as pi over 4. We know that there's 180 degrees in a triangle, so if we have a 90 degree, 45 degree, this one would also have to be 45 degrees, or pi over 4. And we also know from geometry that when two angles have the same measure, their opposite sides have to be equal length. So for convenience purposes, we'll let the side opposite this pi over 4 be 1. Because this is also pi over 4, it has to have an equal length side, so 1. Now, to find our missing piece there, we're actually going to go ahead and use the Pythagorean Theorem. So we can say that 1 squared plus 1 squared equals our r squared. So looks like r equals the square root of 2. So I'll come back over here and I'll change that now to a square root of 2. And for our 45, 45, 90, we have sides 1, 1 with a hypotenuse of the square root of 2. Now, moving into our 30, 60, 90 triangle. To get this going, I'm actually going to start with an equilateral triangle. So a triangle whose sides all have the same length. Now, if that's true, then we're going to have angular measures of 60 degrees for all of them. So if that's 60 degrees, 60 degrees, and 60 degrees, added together, we hit 180 degrees. And using that same property from before, if we have two 60-degree angles, in this case 3, then all of the sides opposite have to be the same. Now, for convenience purposes, I'm going to select a 2 for each length to get started. Now, I'm going to go ahead and from the top vertex come straight down and drop this perpendicular in here. Now, this perpendicular actually bisects that angle. So now we have 30 degrees, and as you can see, we have a 60, a 30, and a 90. So we have everything we need in this one triangle right here. And it also is going to bisect or divide in two the length of the side on the bottom there. So this right here will now have a length of 1. So the only other missing piece would be the actual height. And we can figure that out using the Pythagorean Theorem. We can see that 1 squared plus that question mark squared equals 2 squared. The question mark squared equals 3. So it looks like we get a square root of 3 for the other and remaining side of that triangle. Okay, now I'm going to redraw that picture because it looks pretty messy, but just keep in mind what we're looking at here, guys, is this triangle right here. So we've got a length 1, we've got a height of root 3, and we've got a hypotenuse of 2. We've got 30, 60, and 90. So again, I'm going to take that and I'm going to draw two separate pictures, hopefully ones that are easier to see. Maybe I'll mark that out there. All right, so the first one, there's our 90 degree. We'll say that this is pi over 6. So again, focusing on just this triangle right here, if I label things correctly, this would end up being a 1. The hypotenuse is always a 2. And then we have our remaining side of root 3. The other triangle now, I'll draw with an emphasis on pi over 3. Labeling it correctly, this would be a square root of 3. The hypotenuse is always a 2, and the remaining side would be a 1. So we've got 3 very special triangles that we've put together. This triangle, in this triangle should be devoted to memory very, very quickly. And the more we use it, the easier it'll be. So in these two examples, now we'll just take the information we just learned about and use it for determining cosine and sine of a couple angles. So first thing you might do on the example 5 is go ahead and draw the 45-degree angle in there. So the 45-degree angle would be this right here. So there's our pi over 4. From there, I'll go ahead and drop a perpendicular straight down, which gives us then our right triangle. Labeling things as we came up with in the last slide, this would be a 1, and a square root of 2. So cosine, we know, is the ratio of x over r. If cosine is x over r, and this is our x, this is our r, we find out that cosine of pi over 4 is 1 over the square root of 2. Now, for sine of pi over 3, we'll do essentially the same thing. I'll draw an angle here of pi over 3. I'll drop a perpendicular, labeling it as we just came up with a moment ago. This would be the square root of 3, a 2, and a 1. We know sine is the ratio of y over r. Here's our y, here's our r. So sine of pi over 3 would be the square root of 3 over 2.